Good morning, all of you. Welcome to the J in the rank zone. In the previous session, we have completed salt hydrolysis. Now, in this session, we are going to complete solubility product. It's very, very important. So please listen carefully. Coming to solubility product. Yes, now we're going to start. So, we have completed already salt hydrolysis. Now we are going to start solubility product. So let us listen carefully. What is solubility product? The product of molar concentrations of its ions. The product of molar concentrations of its ions in a saturated solution. Each concentration raised to the power equal to the number of ions produced on dissociation of one molecule of an electrolyte. This is called solubility product. So let us take consideration, for example, barium sulfate. Barium sulfate is a salt which on ionization to form barium plus 2 and sulfate 2 minus ions. So solubility product for this is equal to, if this is equal to S and this is equal to S, so we can say solubility product is equal to concentration of barium plus 2 ions and concentration of SO4 2 minus ions. So this is called solubility product. The product of molar concentrations of its ions in a saturated solution. Molar concentration of its ions in a saturated solution. Each concentration rises to the power equal to the number of ions produced on dissociation of one molecule of an electrolyte. So barium sulfate dissociates to form barium plus 2 and SO4 2 minus. So the solubility product KSP is equal to, for this salt, is equal to Ba plus 2 plus SO4 2 minus. This is called solubility and solubility product. So let us relation between solubility and solubility product. Solubility of a salt is the number of moles of the salt per liter of solution to give a saturated solution. Very, very important definition. Please listen carefully. Solubility of a salt is the number of moles of the salt, soluble per liter of solution. In 1 liter of solution, the maximum solubility of a salt is called its solubility. The maximum amount of solubility is called its solubility to give a saturated solution. Saturated means no more solute can be. What is saturated solution? When no more solute can be added to the when no more solute is added to the solution, then it is called a saturated solution. It is called a saturated solution. Saturated means it is completely over. So when no more solute is added to the solution, then it is called a saturated solution. So solubility of a salt is the number of moles of the salt soluble per liter of solution to give a saturated solution. This is called solubility. So for solubility, we have the types of salts: AB type, A2B type, AB3, A2B3, or AB4 or A4B. These are the different types of salts we have. And how to find solubility and solubility product for these salts, we are going to discuss now. So please listen carefully. For the salt of type AB, one by one I'll write and I'll rub it so that you can understand easily, because in the same slide we are supposed to do the derivation. So please listen carefully. So what is a saturated solution? When no more solute is added to the solution, then it is called a saturated solution. So let us see now type 1 salt, that is salt of type AB. AB type salts, I'll write here the examples. AB type salts. AB type salts. First I'll write example. So please write down the examples. Example 1. It can be NaCl because Na plus Cl minus. Second type, barium sulfate, also coming under AB type salt because the equal number of cations and anions are present. So charge of cation is equal to charge of anion, that is SO4 2 minus. Third, we have nitric acid. Just wait, salt we have to discuss. So right here, sodium nitrate. Fourth one we have sodium nitrate is also coming under AB type salt because it forms Na plus and NO3 minus. And next we have aluminum phosphate dissociates to form Al plus 3 plus PO4 3 minus. So these are all coming under salts of AB type. AB type means where we have the charge on cation and anion are equal. AB type salts are those in which charge of cation and anion are equal. So here I'm writing here charge of cation and anion are equal. They are coming under AB type salts. So you can see here in NaCl, Na plus and Cl minus. So charge of cation is +1, charge of anion is -1. Barium sulfate, charge of cation Ba plus 2 and SO4 2 minus. And sodium nitrate, Na plus and NO3 minus. So AlPO4, that is aluminum plus 3, phosphate 3 minus. So these are all the types of salts which coming under AB type salt. AB type salt means charge of cation and anion are equal. Very, very important. Charge of cation and anion are equal. So how to find solubility and solubility product for AB type salt? So solubility product for AB type salt is S square. How it is formed, I'll just tell you now. So here, as there is no space, I'm rubbing it. So please write down in your classwork what are the types of AB type salts. One type salt I will explain. This slide takes more time because directly they have given the formulas, and now I'm going to tell you how the formulas will be coming. So please note down. So charge of cation and anion are equal. So these are called of AB type salts. Example, NaCl, because it is a strong acid and strong base, so we cannot take this, but still for understanding I have given barium sulfate Ba plus 2 SO4 2 minus, sodium nitrate Na plus NO3 minus. So in all these four types of salts, we can observe that the charge of cation and anion are equal. Charge of cation and anion are equal. They are called as AB type salts. So please note down AB type salts. Now, how to find, let us consider AB type salt like barium sulfate. So barium sulfate dissociates to form Ba plus 2 plus SO4 2 minus. So the solubility of barium plus ions is yes, and it is also taken as yes. So by this you can see solubility about Ksp is equal to product of concentration of ions. Product of concentration of ions. So Ksp is equal to concentration of barium plus 2 into concentration of SO4 2 minus, which is equal to S into S, because concentration of barium plus 2 at equilibrium becomes S, and this is also S. So S into S, S square. So by this you can say implies Ksp is equal to S square, the first one. And to find solubility for this type of salt, root of Ksp. So either they ask us to find solubility product or solubility in the numericals. So how to find solubility product for this type of salts? For the salt of type AB, solubility product is equal to S square. And how to calculate its solubility? S is equal to root of Ksp. S is equal to root of Ksp. So I have given different examples for AB type salt. I hope it is clear. It's very, very important. So to find solubility of AB type salt, S is equal to root of KSP. Either they ask us to find KSP or either they ask us to find solubility. If they have given solubility, they ask us to find KSP. And if they are given KSP, they ask us to find solubility. So depending on the type of salt, we have to apply the formula for solubility. So for solubility for AB type salts, it can be aluminum phosphate, barium sulfate, sodium nitrate, etc. So what is AB type salt basically? If the charge of cation and anion are equal, then it is coming under AB type salt. It can be plus 1 minus 1, plus 2 minus 2, plus 3 minus 3. So we have only three types. So that is called AB type salt. So AB type salt, to find KSP, KSP is equal to S square and S is equal to root of KSP. Next, coming to second type of salt, that is AB2 type or A2B. So AB2 type salt, for example, examples of AB2 I will write here. AB2, calcium fluoride, because the charge of calcium is plus 2 and fluorine is minus 1. So where we do not have, where the cations and anions are not equal, the charge on cation and anion are not equal, they are coming under AB2 type salt. So calcium fluoride, barium chloride, also dissociates to form Ba plus 2 plus 2Cl minus. Next, like this we have AB2 type salts. Next we have A to B type. A to B also coming under same category. So A to B, example, sodium sulfate Na2SO4 dissociates to form 2Na plus SO4 2 minus. So the charge should be balanced. So 2 minus plus SO4 2 minus. Like this we have A to B type salts. So AB2 or A to B, they are coming under category. So these are the examples: calcium fluoride, barium chloride, sodium sulfate, etc. And apart from this, you can write many compounds, like for example, sodium bicarbonate. Sodium bicarbonate is also coming under AB2 type salt, HSCO3, because it forms Na plus, sorry, this is not sodium, magnesium, calcium bicarbonate, because bicarbonate is minus 1. So you can say calcium bicarbonate, and it forms calcium ions plus 2 moles of bicarbonate ion. Bicarbonate is HCO3 minus. Like this, these are coming under A to B type salts. Examples have given, many examples are there. So some examples are given. So in this, what happens? Let us consider calcium fluoride. So calcium fluoride dissociates to form calcium ions plus 2 moles of fluorine ions. The solubility of calcium is S, and this becomes 2S. So by this we can say KSP is equal to S into 2S whole square. This becomes 2S whole square. So this becomes S into 4S square, which is equal to 4S cube. If there is 2 moles, we have to multiply with 2S whole square. So by this you can say KSP is equal to 4S cube. So KSP for this type of salt is how much? It is equal to 4S cube. And solubility for this type of salt, I'm writing here in the first phase, I'm writing here, please note it down. So solubility for this type of salt is equal to, since KSP is equal to 4S cube, hence therefore solubility of this type of salt is equal to cube root of KSP by 4. Cube root of KSP by 4. So in this way we'll find solubility. So in the examination, either they ask us to find solubility or solubility product. So to find solubility, you have to use cube root of KSP by 4. Next, the salt of type AB3 or A3B. So please note down in your classwork to find solve. So in the examination, they can ask either to solve KSP, and solubility. So first thing you have to identify the type of salt given. If they are given the type of salt A2B or AB2, then KSP is equal to 4S cube. So if they are given KSP for that salt, then if they ask us to find solubility. So to find solubility for the type of salt, cube root of KSP divided by 4. Cube root of KSP divided by 4. The cube root will be coming for entire this thing. So this is clear. Next continuation, third type of salt. Third type of salt, AB3 type. So AB3 type or A3B type. So for this, I'll write one example, AB3 type, AB3 type, AlCl3, aluminum chloride, because aluminum chloride dissociates to form Al plus 3 plus 3Cl minus, and A3B type. So if you take A3B type, A3B, example, sodium phosphate, Na3PO4. So dissociates to form 3 sodium ions plus phosphate ion PO4 3 minus. So how to find solubility for this? So for this solubility is nothing but S into 3S whole cube. S into 3S whole cube. For this 3S whole cube, wherever you have number of moles, for that you will get like this, and this is S. So for this KSP, for this type of salt, KSP is equal to 3S whole cube, it is 27S power 3, and one more S is there. So 3S whole cube into S, which is equal to 27S power 4. So this is called 27S power 4. In this way you will get. And to find solubility for this type of salt, solubility is equal to 4th root of KSP by 4, 4th root of KSP by, sorry, 4th root of KSP by 27. Normally for this type of salt, they ask us only to calculate KSP, not solubility, because it is difficult to find this answer. So generally you'll get like this. So I hope you understood this. So AB3 or A3B, AlCl3 dissociates to form Al plus 3 and 3Cl minus. For this the solubility is yes, and for this the solubility is becoming 3S whole cube. 3S whole cube. And for this also again sodium charge is 1. So 3S whole cube into S. So by this we can write for this both type of salts KSP is equal to 3S whole cube into S, that is 27S power 4. So for the salt of type AB3 or ATB, KSP is equal to 27S power 4. So usually they'll ask this type of questions only. In this type of salt, they ask only to find out KSP value, not solubility. Because solubility, if they ask us also, they give solubility value and they ask us to find KSP. You may not get this because even this is formula is correct only, but you may not, because this calculation part is more bigger. So usually they will not give that much big calculations in the entrance exams. So for this type of salt, they ask us to find only KSP. One thing, whenever they have given the numerical in this type of questions, for they ask us to find solubility product, basic thing is very important, that you have to identify the salt of type. If the salt of type is given as AB, then KSP is equal to S square. AB2 or A2B, KSP is equal to 4S cube. So for every type of salt, the formula is changing. So that's why it's very important to identify the type of salt. Until and unless if you don't identify the type of salt properly, you may not get correct answer. So please listen carefully and try to identify the type of salt given in the entrance examinations whenever you are writing the exam. Next, salt of type A2B3 or A3B2. So with this, I am clearing this because there is no space here to show one by one, because the slide is prepared like this. So I'm writing here itself for each and every type salt. So please listen carefully. So we have discussed 1, 2, and 3 types of salts are over. Now we are discussing fourth type of salt, that is A2B3. A2B3 means, for example, aluminum sulfate, A2B3. aluminum sulfate dissociates to form 2Al plus 3 plus 3SO4 2 minus 3SO4 2 minus 2Al plus 3 plus 3SO4 2 minus. So aluminum sulfate. So aluminum sulfate is Al2SO4 taken place. It is changing to 2Al plus 3 plus 3SO4 2 minus. So the solid and one more is what? A3B2. A3B2 straight away we can write Mg2SO4 taken place. Magnesium sulfate. Or you can say, sorry, magnesium phosphate. Mg2PO4 taken thrice. Or even you can write barium phosphate. Better to write barium phosphate because it is sparingly soluble salt. So barium phosphate Ba2PO4 taken thrice. This dissociates to form 2Ba plus 2 Ba2. Sorry, this is not correct formula. Since we have done A2B3, now we have to write A3B2. A3B2 means Ba3PO4 taken twice. Ba3PO4 taken twice dissociates to form 3Ba plus 2 plus 2PO4 minus 3. So if you multiply, the charges should be balanced. 3 to the 6, 2 3 the 6. So these are the types of salt example for A2B3 and A3B2. For this type of salt, let us take A2B3 or A3B2. The solubility of this becomes S square because 2 moles, and this becomes 3S whole cube. Similarly here, the solubility of this salt becomes 3S whole cube into S square. So KSP becomes, however, KSP becomes 3S whole cube into 2S whole square. So this is 2S whole square. I'll rub it again. This is becoming, since 2 moles are there, so 2S whole square. And this becomes 2S whole square. So 3S whole cube into 2S whole square. This is 27S cube into 4S square. So this becomes 108 S power 5 because 28 into 4 is 108. So 108 S power 5. So usually for this type of salt, they'll ask only the formula, no need to substitute also. So and how to find solubility? Solubility is equal to fifth root of KSP by 108. So please note down this type of salts. Here no derivation is given, so I'm deriving the formula also. So A2B for the fourth type of salt, it is A2B3 or A3B2. So A2B3 aluminum sulfate Al2SO4 taken thrice changes to form Al plus 3, 2 into 2 moles of Al plus 3 plus 3 moles of sulfate ions. So it is changing to 2S whole square, 3S whole cube. And barium phosphate, that is A3B2, A3B2. So A is barium and B is phosphate here. So 3 moles of barium plus 2 ions and 2 moles of phosphate 3 minus ions. So on multiplying this, 3S whole cube into 2S whole square. So anyway, this is same. So KSP for this type of salt is equal to 108 S power 5, 108 S power 5. And solubility for this type of salt becomes fifth root of KSP by 108, fifth root of KSP by 108. So this is the concept here. Very, very important. Please note it down. Please note it down. As we don't have space for one type of salt, I'm deriving the formula and I'm clearing it. So you also do the same, but you just write down for one type of formula and one type of salt, and you have to write down all these things. Next, we'll check your classwork so that you have to note down all these things in your classwork. Then only you can able to understand and substitute the formula. Next. For the salt of type AB4 or A4B, usually you'll not get this type of salts. Very rarely we have this type of salts. So these type of salts are very rare. And for this type of salts, let us take AB4. AB4 means charge of anion is 4 and charge of cation is 4, sorry. So it is A4 plus B minus. So for this, the solubility becomes, sorry, 4B minus, 4 into B minus. I'll make it clear. A4 plus 4B minus. So 4B minus for this solubility is yes, and for this solubility becomes 4S whole power 4. So 4 square 16, 16, 16 into 4, 64, 64 into 4, 256. So KSP becomes 256 S power 5. 256 S power 5. So solubility is equal to fifth root of KSP by 256. And A4B also same, reverse of this. So you'll get like this type of salts. These salts are very rare. So if you want to take example, you can take stannous chloride, SnCl4. Stannous chloride, in this stannous chloride dissociates to form Sn plus 4 plus 4Cl minus. Usually in this, they are not stable. So for this, that KSP is equal to S, and for this, it becomes 4S whole to the power of 4. How many moles that power will come? So it becomes 256 S power 5. KSP is equal to 256 S power 5. So in this way, you'll get the answer. Please note it down. So these are the different types of salts and how to find solubility product for different types of salts we have completed. So first type, salt of type AB, it is KSP is equal to S square and S is equal to root of KSP. Till here they'll ask. And second type AB2, S is equal to KSP is equal to 4S cube. So S is equal to cube root of KSP by 4. So like that you can write everything. For the salt of type AB3 or A3B, KSP is equal to 27 S power 4. For the salt of type A2B3 or A3B2, KSP is equal to 108 S power 5. And last type of salts are very rare. So KSP is equal to 256 S power 5. How we got 256 S power 5? I already told you 4S to the power 4 means 4 4s are 4 into 4, 16, 16 4s are 64, 64 4s are 256. So 256 S power 4 into S, that becomes 256 S power 5. So this is the types of salts and how to find solubility product and its solubility. So in the examination, either they ask us to find solubility product or solubility. So in any case, they have to give either one of the two. Either one of the two they have to give in any case. So these type of questions are important in the examinations. If you see previous JEE means papers, NEET papers, so many questions have come from this concept. Very, very important. So please note it down. Next, we'll continue with the topic. Relation between solubility and a solubility product continuation. In general, for a given type of salt AXBY, x power x into y power y into solubility x power solubility to the power x power y, where S is called solubility of the salt. This is the integrated equation. Even this also they will ask in the examination. So please note it down. So how to find KSP for the salt of type AXBY, A moles of AXBY, x power x into y power y into x power x plus y, where S is called solubility of the salt. So this is very, very important. Please note down. This is a general form of writing solubility product. General form of writing solubility product. Next continuation. Now let us take some questions. Apart from this, we have one more topic also to find solubility having common ions, that also we'll discuss. So solubility of silver chloride in water at 25 degrees is the solubility of silver chloride. They have given S. This is the value of S, that is 1.7 into 10 to the power minus 3 grams per liter. Calculate KSP of AgCl. Straight away, since AgCl dissociates to form Ag plus and Cl minus. So the solubility of Ag plus is yes and Cl minus is also yes. So KSP is equal to, since it is of type AB type salt, so KSP is equal to S square, and S value is given already. So therefore KSP is equal to 1.79 into 10 to the power of minus 3 whole square. So it is approximately equal to 1.79 into 10 to the power of minus 3 whole square. Sorry. 1.79 into 1.79, which is equal to 3.2041. 3.2041 into 10 to the power of minus 3 whole square is 10 to the power of minus 6. So answer is 3.2 into 10 to the power of minus 6 approximately. So let us check the answer now. So 1.55 into 10 to the power of minus 4, it is wrong because the solubility is given. The solubility of AgCl in water at 25 degrees is 1.79 10 to the power of minus 3. So 1.79 whole square, it is equal to 1.79 into 1.79. If you multiply, you will get 3.2041 into 10 to the power of minus 10. It is absolutely wrong. So you have to check the answer. So answer is KSP. So this answer is wrong. Answer is this correct one. 3.2041 in 10 to the power of minus 6 because it is of the salt of type AB. For AB type salt, KSP is equal to S square. Since S is equal to 1.79 in 10 to the power of minus 3 because the solubility is given. So solubility square. So 1.7 in 10 to the power of minus 3 whole square. You get the answer. Next, continuation. Effect of common ion on solubility. This concept is very, very important. If common ion is present, then the solubility will change. So let us discuss now. Consider saturated solution of AgCl, silver chloride. If a salt having either of the ion common to AgCl, say KCl, because common ion is Cl minus, is added to it, then AgCl dissociates to form Ag plus and Cl minus. KCl also dissociates to form K plus and Cl minus. So for AgCl, Ksp is equal to Ag plus Cl minus, and Cl minus ion concentration increases in solution due to presence of KCl. Very, very important. Please note down. How to find Ksp for AgCl? Asp is equal to Ag plus into Cl minus, concentration of Ag plus into Cl minus. And in the second case also we have Cl minus. So Cl minus ions, we have two Cl minus ions. How many Cl minus ions? Two Cl minus ions, because in these two common ion is chlorine. So chlorine concentration, chlorine ion concentration increases in solution due to presence of potassium chloride, and thus to have Ksp constant, Ag plus will decrease or AgCl will precipitate out from the solution. That is, solubility of AgCl will decrease with the increasing concentration of potassium chloride solution. And to find solubility of chlorine, solubility is equal to Ksp by C. New solubility Ksp by concentration of C. So this is the formula for finding solubility. Anyway, we are going to discuss this type of questions. So due to the presence of common ion, what is our final concept here? Due to the presence of common ion, the solubility of the salt will decrease with the increasing concentration of common ion solution, that is potassium chloride in solution. So the solubility of a salt will decrease if you add the any other salt which has common ion. So due to the common ion effect, the solubility of a salt decreases. The solubility of a salt will decrease due to the common ion effect. So effect of common ion solubility will be like this. So the solubility of silver chloride will decrease with the increasing concentration of potassium chloride in the solution. So this is due to, because in AgCl also Cl minus will form, and KCl also Cl minus will form. As concentration of Cl minus increases in the solution due to presence of potassium chloride, and thus to have Ksp constant, silver ions concentration of silver ions will decrease, or AgCl will precipitate out from solution. That is, solubility of silver chloride will decrease, because that is, as it is precipitating out, means what? The solubility is decreasing. So the solubility of silver chloride will decrease with the increasing of concentration of potassium chloride in the solution. So this is very, very important. Please note it down. So by this, what you can understand finally, the solubility of a salt decreases with the increasing concentration of common ion. With the increasing concentration of common ion, due to common ion effect, the solubility of a salt decreases. Simple word. the solubility of a salt decreases due to common ion effect. Common ion effect. Continuation. So let us take 0.1 molarity potassium chloride aqueous solution with silver chloride solution. If solubility of silver chloride is S moles per liter, then for solid silver chloride Ksp is equal to S into S plus 0.1 because due to presence of common ion. S being very small in comparison to 0.1, thus may be neglected. Therefore, Ksp is equal to S into 0.1 or S is equal to Ksp by 0.1. As I told you, to find new solubility, Ksp by C. What is C? Concentration, that is 0.1. So where C solubility of silver chloride in the presence of 0.1 molarity potassium chloride. So this formula is very, very important. Ksp by 0.1. C is called concentration of the common ion adding. So when common ion is added to the salt to find new solubility, Ksp by C. After finding new solubility, you can find, so they'll ask us to find new solubility, that is Ksp by C. Ksp by C. And this formula is only applicable for AB type salt. AB type salt. If they are asked AB2 type, then the formula will change. That also I'll show you. So in this way, we'll find out common ion effect solution. So if they are given common ions in the salt, definitely they'll ask us to find new solubility after adding that common ion. So when 0.1 molarity of potassium chloride solution is treated with silver chloride solution, due to the presence of common ion, that is chlorine ions, the solubility of AgCl decreases. And to find new solubility of AgCl, Ksp of AgCl by C. Ksp of AgCl by C. So in this way, you'll find very, very important. Please note it down. When you solve numericals, you'll understand in better way. Next, applications of solubility. Prediction of precipitation of salt. First application is what? It is helping in prediction of precipitation of a salt. Salt gets precipitated only when the ionic product exceeds the solubility product. If the ionic product, for example, let us say Ksp value will be different, ionic product. Generally, they should be same. For example, ionic product means like concentration of barium plus ions for barium sulfate solution. So if the ionic product of barium ions and sulfate ions. If the ionic product of barium sulfate ions and the product, for example, this is this S square. So if S square is greater than Ksp, and the ionic product exceeds the solubility product Ksp, then precipitation takes place. Precipitation takes place due to the common ion effect. Precipitation takes place. So please note it down. If the ionic product exceeds If the ionic product exceeds the solubility product, precipitation takes place. Next, purification of common salt. By passing HCl gas through a saturated solution of NaCl, solubility of NaCl decreases and pure NaCl gets precipitated. So by the, what is the common ion here? Cl minus and Cl minus. So due to the common ion, what happens? The solubility of silver chloride decreases in the solution. So pure sodium chloride gets precipitated. So that's why we can say, based on the solubility, by adding a suitable reagent, we can decrease the solubility and makes it happen to separate out, that is precipitated. In this way you have to do. So I think you understood clearly. And next case, when you are doing problems numericals on this, you'll understand more better way. Now let us see next one. Ksp of silver chloride is 1.5 10 to the power of minus 10. Calculate solubility of AgCl in 0.1 molarity silver nitrate. So silver chloride Ksp is given and silver nitrate solubility they are asking. When calculate solubility of silver chloride in 0.1 molarity silver nitrate. So here silver chloride is there as well as, silver chloride is there as well as silver nitrate. So silver chloride dissociates to form, as we know, Ag plus Cl minus, and sodium silver nitrate dissociates to form Ag plus nitrate ion. So by using this, these are the two common ions. Silver ions are common in this. So Definitely the solubility of silver chloride will decrease due to the presence of silver nitrate. So to find new solubility nu is equal to, what is the formula I told? It is equal to Ksp of silver chloride by concentration by C. What is the concentration of silver nitrate? 0.1. So it is equal to Ksp 1.5 10 to the power of minus 10 by 0.1, 0.1. So it is equal to 10 to 0.1 can be taken as 0.10 to the power of minus 1 and 10 to the power of minus 1 going to numerator. So I'll write it here clearly. 1.5 10 to the power of minus 10 divided by 10 to the power of minus 1. So 10 to the power of minus 1 going to numerator. So finally it becomes 1.5 10 to the power of minus 9. 1.5 10 to the power of minus 9. So this is the answer. As I told you, 1.5 10 to the power of minus 9 moles per liter. This is called solubility using common ion effect. Common ion effect. What is this called? This is called common ion effect. As I told you, you will understand better by solving a numerical. So here the Ksp of silver chloride is given as 1.5 10 to the power of minus 10 at 25 degrees C. And you need to calculate solubility of silver chloride in 0.1 molarity silver nitrate. So silver nitrate solution. What happens to the solubility of this solution in silver nitrate? And how much concentration of silver nitrate? 0.1 molarity concentration of silver nitrate. So to find new solubility of silver chloride, that is solubility new I wrote here, new solubility of silver chloride. So silver chloride new solubility is equal to Ksp by C. So that is equal to, since C is equal to 0.1, we can take it as 10 to the power of minus 1. 10 to the power of minus 1 going to the numerator, 10 to the power of plus 1. 10 to the power of plus 1, 10 to the power of minus 10 becomes 10 to the power of minus 9 moles per liter is a unit, common unit. So is this clear? This is the answer. So this type of questions are most important for NEET and JEE mains and advanced also. Next, continuation. So now we'll write questions, some more problems based on solubility product so that we can wind up this topic effectively. So questions based on solubility product. So I'll do some different models. Questions on solubility product. So two types we have done. So first question now. Questions based on solubility product. If you solve this type of questions, it will be very easy for you to understand the solubility of type 1 now. The solubility of, these teacher's choice questions so that the students can understand better. The solubility of calcium fluoride is 2 in 10 to the power of minus 4 moles per liter. Moles per liter. Next, its solubility product is, its solubility product is option A, 2 into 8 in 10 to the power of minus 12. This is only substitution part. Option B, it is 4 in 10 to the power of minus 8. Option C is 4 into 8 in 10 to the power of minus 12. 4 into 8 into 10 to the power of minus 12. And option D, it is 3.2 in 10 to the power of minus 4. So these are the four options they have given. Let us see the solution now. First, for solving this type of questions, we need to identify the type of salt. Since calcium fluoride is AB2 type, AB2 type salt. Even if you don't remember AB2 type salt also, simply you can say calcium fluoride dissociates to form Ca plus 2 plus 2F minus. So the solubility for this becomes S and this becomes 2S whole square. So it becomes, so therefore KSP is equal to 4s cube. KSP is equal to how much? 4s cube. So we can write it as 4 into 2 into 10 to the power of minus 4 whole cube. This is equal to 4 into 2 cube is 8 into 10 to the power of minus 12. So answer is C. In this way you have to calculate. Since calcium fluoride is AB2 type salt, because calcium fluoride dissociates to form Ca plus 2 plus 2F minus. So solubility of calcium is S because it is only 1 mole, and this is 2 moles, so 2S whole square. So it becomes solubility product is called 4S cube. Since S is equal to, they are given how much? S is equal to 2 into 10 to the power of minus 4. Since S is equal to 2 into 10 to the power of minus 4, which is they are given already because the value of S, because S is equal to 2 into 10 to the power of minus 4. So 4S cube means 4 into 2 into 10 to the power of minus 4 whole cube. So it is equal to 4 into 8 into 10 to the power of minus 12. 10 to the power of minus 12. So answer is C option. Next question. So this is clear now. Next question. Question number 2. The solubility of silver chloride. The solubility of silver chloride AgCl in 0.1 molarity NaCl is given. Ksp of silver chloride is equal to 1.2 10 to the power of minus 10. Is as simple as simple. We have done it already. 1.10 to the power of minus 10. So first option, that is A, option A, 0.05 molarity. Option B, 1.2 10 to the power of minus 4. Option C, 2 in 10 to the power of minus 5. And option D is 1.2 in 10 to the power of minus 9. Yes. Now let us see the solution. Since you already we have done this part in the PPTs. So I hope it is clear. So this is nothing but silver chloride and NaCl. So the common ion is Cl minus. Therefore, the solubility of silver chloride decreases due to increase in concentration of Cl minus. So to find new solubility, therefore solubility of new solubility, that is silver chloride solubility in NaCl is equal to Ksp by C. So Ksp is equal to given already 1.2 in 10 to the power of minus 10 divided by C, that is equal to 0.1, which is equal to 1.2 in 10 to the power of minus 10 divided by 10 to the power of minus 1, which is equal to 1.2 in 10 to the power of minus 9. So answer is 1.2 10 to the power of minus 9. That is fourth option. So in this way, you have to see for common ion effect. For common ion effect, solubility of silver chloride decreases due to increasing concentration of Cl minus. So new solubility of silver chloride becomes Ksp by C, that is Ksp of AgCl by C, that is concentration of sodium chloride. So 1.2 10 to the power of minus 10 by 0.1. It is equal to 1.2 in 10 to the power of minus 10 by 10 to the power of minus 1, which is equal to 1.2 10 to the power of minus 9 finally. So answer is D option. This is clear. Next, very important model. Next model. So this is basic two models. Now next model number 3. The solubility product of MOH. If the solubility product is also important model. Solubility product of MOH. This is the type of salt MOH is 1 in 10 to the power of minus 10 molarity. 1 into 10 to the power of minus 10 molarity. Then pH of its aqueous solution will be then pH of its aqueous solution will be. So they are asking us to find pH also by using solubility product. Aqueous solution will be very important. Extension problem will be option A. It is 11. Option B. It is 9. Option C. It is 13. And option D. It is 5. So instead of asking solubility, they are asking solubility product. For this type, first we need to find. So since MOH is AB type salt because OH minus ion, because AB type salt, therefore KSP is equal to S square implies S is equal to under root of KSP. So first we'll find solubility. So solubility S is equal to under root of KSP, and that solubility becomes OH minus ions. So solubility is equal to root of 1 into 10 to the power of minus 10, which is equal to 10 to the power of minus 5. And this solubility is nothing but, so concentration of OH minus ions is equal to, since OH minus ions is there, is equal to 10 to the power of minus 5, implies POH is equal to negative logarithm of 10 to the power of minus 5. So it is equal to 5. Since therefore pH is equal to 14 minus 5, 14 minus POH. So it is equal to 14 minus 5, which is equal to 9. So answer is second option. Answer is what? Second option. So in this way, this is the extension of KSP. So first, when they are given the solubility of MOH is 1 in 10 to the power of minus 10 molarity, then pH of its solution will be, so more solubility product of, sorry, here we have tried solubility, no, is solubility product. That's what I have taken, solubility product. If the solubility product of MOH type salt is 1 in 10 to the power of minus 10 molarity, then pH of its aqueous solution becomes. So then pH of its aqueous solution will be, so as they have given solubility from the solubility product, we can find solubility by identifying the type of salt. Since MOH is AB type salt, so KSP is equal to S square, implies S becomes root of KSP, and that S becomes concentration of OH minus. Since this is OH is given, so this S becomes 10 to the power of minus 5. So this concentration of OH minus straight away we can take by this concentration of OH minus is equal to 10 to the power of minus 5. And POH is equal to minus log of 10 to the power of minus 5. It is nothing but 5 minus log 10 to the base 10. So it is 5 log 10 to the base 10. It is equal to 1. So it is equal to, since log 10 to the base 10 is 1, so it is equal to 5. And since pH is equal to 14 minus POH, so 14 minus 5 is equal to 9. So like this extension type questions they'll ask in the examination. Even you may expect the same question also. Very important this model. I hope it is clear. Next, model number 4. Question number 4 we are going to discuss now. This is also different model. What is the, is for advanced level, it is very important. Or JE means level. Usually you may ask for NEET also. What is the minimum, what is the minimum concentration of SO4 2 minus concentration of SO4 2 minus required to precipitate, required to precipitate barium sulfate in a solution of, in a solution containing 1 into 10 to the power of minus 4, 1 into 10 to the power of minus 4 mole of barium plus 2 ion, mole of Ba plus 2 ion, given Ksp of barium sulfate is equal to, Ksp is equal to, I'll write it here clearly, given Ksp of barium sulfate is equal to 4 into 10 to the power of minus 10. Option A, this model is very, very important. 2 into 10 to the power of minus 3 molarity. Option B, 2 into 10 to the power of minus 5 molarity. Option C, 4 into 10 to the power of minus 10 molarity. And option D, 4 into 10 to the power of minus 6 molarity. So these are the options they have given. Very, very important model, this question. So what is the minimum concentration of SO4 minus 2 minus ions to get precipitate? So for this, I'll write the solution here. Solution I'm starting here. To get precipitate, since we already know precipitate, ionic product should be greater than, ionic product should be greater than Ksp. Therefore, the minimum concentration of sulfate ions, the minimum concentration of sulfate ions to get precipitate is equal to Ksp divided by concentration of barium plus 2 ions. Ksp divided by concentration of barium plus 2 ions, because since Ksp of barium sulfate is equal to concentration of barium plus 2 ions into concentration of sulfate minus 2 ions. So the minimum concentration is equal to Ksp by barium plus 2 ions. So what is the Ksp value of this? Is equal to 4 into 10 to the power of minus 10 divided by, what is the value of concentration? 1 in 10 to the power of minus 4. So 10 to the power of minus 4 divided by, so it is equal to 4 into 10 to the power of minus 6. So option is fourth option. So this model is very, very important. So please do it. These type of questions are most important in the examination. Very, very important questions. Definitely you are going to get one question like this. So what is the minimum concentration of sulfate ions required to precipitate barium sulfate in a solution containing 1 in 10 to the power of minus 4 molarity of moles of barium plus 2 ions? Given Ksp of barium sulfate is equal to 4 in 10 to the power of minus 10. So since they have given Ksp, to get precipitate, what is the condition? Ionic product should be greater than Ksp. This condition is very, very important. So the ionic product should be greater than Ksp. If the ionic product is greater than Ksp, So automatically you'll get the salt will get precipitated. So the minimum concentration of sulfate ions to get precipitated is equal to Ksp by barium ions. So it is equal to 4 into 10 to the power of minus 10 by 1 into 10 to the power of minus 4 is equal to 4 into 10 to the power of minus 6. Very, very important model. Please do it in your classwork. Next question. So these are the important models we have. I hope you have copied it. I have given enough time for you to copy. So these are the important models we have in solubility. So common ion effect, how to find solubility by giving KSP or KSP by giving solubility, and how to identify if they are given solubility, how to find KSP, that is based on the type of salt. So all the four models, important models, and apart from this, two more models I have done. So these four models are very, very important for the examination from this concept. Even we know how to find KSP of even this pH also. From KSP, how to find pH also. So these are the models which we have done. All are very important. So if a salt has to be precipitated, what happens? The ionic product should be greater than KSP. So they'll give concentration of salts and they ask us, they'll give KSP values and they ask us even whether the salt is getting precipitated or not. So further, simply you have to type, you have to do product of concentration of salts and you have to compare with KSP. Then automatically you can understand whether the salt can be precipitated or not. So that type of questions are also very important. So please listen carefully. And we have done enough models in this solubility product. We have done enough models in this soluble product. So with this, I'm ending this session. The next session we'll come up with a new topic. So please listen carefully and follow our instructions strictly so that you can do the concept easily, you can understand the concept easily, and you can do all the questions in other competitive books also by using this concept. So with this, I'm discontinuing this lecture. Thank you. Thank you all.